Use the graph to check continuity of the function at each of the integers in the domain. Recall that f is continued at x equals a only if the limit at x equals to a of f of x equals f of a. The limit needs to exist, meaning the left and the right hand side limit exists, and the limit needs to be the same at the value of the function at that point it is approaching. We also consider the definition of continuity from the left or from the right for the endpoints in the domain. Using the definition of continuity, we would need to evaluate the function at each of the integers, as well as finding the limit, both two-sided, left side, right side. The integers in the domains are 0, 1, 2, 3, and 4. f of 0 is 1. f of 1 is 1. f of 2 is 2. f of 3 is 2. And f of 4 is 1/2. Looks like it is 0.5. When evaluating the function using the graph, we would need to use the closed circle. As x goes to 0 from the right hand side, because there's nothing on the left hand side, from the right hand side of 0, the limit is approaching 1. Since the function doesn't exist on the left hand side of 0, and the limit at x goes to 0 from the right hand side of f of x equals f of 0, we say that the function f is continued at x equals 0, but from the right only. When x equals 1, the limit at x goes to 1 from the left hand side is 0. The function is approaching y equals 0. On the right hand side, the function is approaching 1, so the limit at x goes to 1 from the left hand side is 0. The limit at x goes to 1 from the right hand side is 1. And so the two-sided limit does not exist. And so we would say that the function is not continuous at x equals 1. Moving on, at x equals 2, the left-hand side limit is 1, and the right-hand side limit is also 1. Notice that at x approaches 2, from both sides, the left and the right, the y value is approaching 1. And so we see that the two-sided limit at x approaches 2 is 1. So the limit exists. However, the value of the function at x equals 2 is 2. And so the limit and the value of the function do not agree. We say that the function is not continuous at x equals 2. As x goes to 3 from the left-hand side, the function is approaching 2, and the function also approaches 2 from the right-hand side of 3. And so the limit on the left of 3 is 2, from the right of 3 is 2, and therefore the limit at x goes to 3 of f of x is 2, and this limit agrees with the functional value, so we see that the function is continuous at x equals 3. And so f is continued at x equals 3. At x goes to 4 from the left-hand side, the limit is 1. There's nothing on the right-hand side of 4, so we won't find the limit on the right-hand side of 4. The value of the function at x equals 4 is 1/2, and this does not agree with the limit on the left-hand side. And so we say that the function f is not continuous as 4. And so for all of these integers, the function is continuous at x equals 1 from the right. And also, it is continuous at x equals 3. The function is not continuous at x equals 1 because there is a jump. And the function is not continuous at x equal 2 because there is a removable.